Here's a demo of my project, the simulation part in MATLAB. This is the initialization file where the random bits are generated. And yeah, that's the file actually. Random bits are generated, and also some common parameters like the carrier frequency, the energy of the signal pulse, and number of samples per symbol, and total length of the signal. All these is set. Yeah, that must do fine. And then I have the baseband PSD is plotted by this script, and then yeah, g of t is defined, and then the Fourier transform of that taken, and according to the formula from the presentation before, the uh, power spectral density is plotted in dBs versus the frequency in terms of multiples of the bit rate. And yeah, the first basic modulation technique is QPSK. QPSK is just it splits the bits into even and odd ones, and converts them to NRZ format from the zeros and ones. And then this is the rectangular pulse, and it generates the in phase and quadrature signals in the baseband. And then there is a modulate function, which takes the in phase and quadrature components from the QPSK or OQPSK, whichever routine modulation we do, and then it modulates the carrier components accordingly and gives the final signal. So let me do the example for you. First we initialize, and that's the random bit sequence that's generated. That is our information sequence. And then we do QPSK. Thus we get the QPSK signal. Like I can just show you. Yeah, these are the first 5 bits, and yeah, let me first modulate it, and then we get the signal of equal to, yeah. So now let me plot the signal. Yeah, you can see the phase shifts that's happening every 40 samples, because the symbol duration is 40 samples, and it changes according to the bit random bits here. Yeah, that is QPSK. And now if you want to plot, there is a plot power spectral density routine, which takes any signal and defines the autocorrelation function, does the Fourier transform of it, and plots it. I'm plotting, and this plots only the positive frequencies. So let's plot the QPSK signal we just generated. Yeah, that's the QPSK power spectral density. Next we'll do OQP. Okay, OQPSK will be same as QPSK, except that the quadrature component is given a final offset. That's the only difference. and so we can see the and now if we plot the PSD of this, yeah, so this is for QPSK and this is for OQPSK. You can see that the OQPSK plot is similar to QPSK. This is MSK as a pulse shaped OQPSK. So it just splits the bits into odd and even bits, and instead of the rectangular pulse, it uses the sine pulse. And there's other things are same as the shifted version of QPSK. So let's do MSK in this way. Yeah, this way MSK again generates in phase and quadrature components, and we have to modulate it again. Once we modulate, we can see we can see that the very slight frequency change is there. The frequency is low here, there's bigger gaps, and the frequency is high here. So this changes every 20 samples because now MSK is equivalent to frequency shift keying for every uh, time interval, bit interval, but the modulation is for the differential code. So the same MSK we can generate by considering it as FSK, and yeah, this is the code for that as a CPFSK. The modulation index is 0.5, and the phase is changed. The phase depends on the differential coded. This is the differential coded bits from our bit sequence, and the phase of the signal is changed. So this doesn't need modulation. The modulation is included in the file. Yeah, MSK FM gives the MSK directly. Yeah, and if we plot the PSD of this, yeah, you can see that it goes almost to 60. Okay, to compare it with the QPSK plot, here, this is the QPSK plot, and this is the MSK plot. It has come down significantly, and next is GMSK, which is same as the MSK FM, which I showed before. Yeah, it is same as that, only that the phase is not a straightforward calculation now, it's not linear. So first we make a sample pulse by passing the rectangular pulse through a Gaussian filter, and then we pre-calculate and create a phi table of all the changes in phase, and then we use that to modulate the carrier. So that's the only difference, and we can see. Yeah, so here's the PSD for GMSK. Yeah, you see that it goes to minus 60 dB eventually, and it falls more rapidly than the QPSK or normal MSK. I'll just do a QPSK for you to refer back. Yeah, that's the QPSK, and this is the GMSK. See how rapidly it falls compared to it. So that's the main advantage we see in GMSK. Thank you.